We know that the most significant contributor to global warming is excess carbon in the form of carbon dioxide gas in the atmosphere. But did you know that our soils are actively being depleted of carbon and need more carbon to be healthy? Since the Industrial Revolution, the way we traditionally farm has changed drastically. Agriculture in many parts of the world has shifted to monoculture and resorts to heavy machinery, the application of herbicides and pesticides, and the addition of fertilizers. There are many environmental issues relating to these practices, but today, I'm here to discuss just one of those issues: the loss of carbon in soil. Soil is the second largest active carbon store after the oceans. It accounts for 80% of terrestrial carbon storage and is estimated to hold 1,500 billion tons of organic carbon in the top meter. To compare, the atmosphere holds 800 billion tons of carbon. In other words, the soil carbon pool is roughly twice the size of the atmospheric pool. Although the oceanic carbon pool is much larger in size, the rate of exchange between it and the atmosphere is much slower than it is with soil. What is soil? Soil is believed to have originated over 2,000 million years ago as the product of mechanical and chemical weathering of rocks and sediments. Weathering is still occurring, but soils of today are a complex mixture of water, air, minerals, and organic material which are essential to plant growth. During plant growth, atmospheric carbon dioxide is fixed by photosynthesis into plant biomass, which in turn feed microorganisms through their roots. In return, these microorganisms extend the root system and provide more nutrients back to the plant. When the plant dies, it decays and releases some carbon back to the atmosphere. However, some carbon is left behind to form an organic, rich material called humus. Humus is resistant to decay and leads to longer carbon residence time in soils. As microbiology and dead plants accumulate in the soil, so does carbon storage. Unfortunately, microbiomes are destroyed through intense tilling. It also causes the soil to dry up, to compact, and to lose much of its nutrients by erosion. Specialists have estimated that we will run out of arable land in the next 50 to 60 years. The solution to this problem is regenerative farming. Regenerative farming represents a transformative approach to agriculture that not only seeks to mitigate the environmental impacts of conventional farming, but also aims to restore ecosystems and enhance soil health for future generations. As consumers and policymakers increasingly recognize the importance of sustainable food production, supporting regenerative farming practices can play a pivotal role in building a more resilient and environmentally friendly food system while sequestering carbon out of the atmosphere. It's important for urban gardeners to do their part in this mission as well by harnessing the potential of underutilized green spaces in our neighborhoods. Imagine the amount of carbon that could be captured from private yards, parks, and sidewalks.